this uh, tetrasulfate acid. So what do you expect again? Zinc will send away the hydrogen and combine with the SO4. Zinc, SO4. They are both having valency of 2 2. So that will give you ZnSO4. Then the hydrogen will be left alone as a displaced element gas. So you want to know why the aluminum chloride here is AlCl3. Aluminum and chlorine. Aluminum is number 13. That's a 283 configuration. So the valency of aluminum will be 3. So talk about 3 here. Chlorine is number 17. That's a 287. Valency is 8 minus 7, 1. So when you exchange the valency like this, that will give you aluminum 1, Cl3. That's how aluminum chloride is AlCl3. The same thing also goes for MgCl2. Valency of Mg is 2. Valency of chlorine is 1. So when they combine, they exchange valency to give you MgCl2, and hydrogen gas is displaced. These are metal acid reaction. We have examples of a metal acid reaction here also. Zinc plus HCl. The valency of zinc is always 2. Take note of that. You might not be familiar with zinc, but the valency is always 2. So when zinc displaces hydrogen and picks up chlorine, so you want to check their combining power. Zinc valency is 2, chlorine valency is 1. That will give you a ZnCl2 that we have in this place. You can see all these AQ gas, their physical state. You're already familiar with that. Metals always occur in solid form, apart from mercury, which is liquid. So in this place also, magnesium plus H2SO4, we have seen this also. Zinc plus H2SO4, we have also seen that. Iron 2 plus H2SO4, that will be iron Fe2. SO4 is also valency 2. So that will be FeSO4. So those are examples of acid metals reaction giving us a salt and hydrogen gas. Now, not all metals can displace hydrogen. Not all metals can displace hydrogen. You know, when you are displacing hydrogen, the sign is that you are higher, you are more reactive than hydrogen. And not all metals are more reactive than hydrogen. That's why we have this activity series. We call this activity series, where potassium is first, followed by sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. All the metals below hydrogen here, all these metals cannot displace hydrogen. So when you throw them inside dilute acid, no reaction will occur because they are lower than hydrogen in the activity series. They are lower than hydrogen in the activity series. So not all metals can react with dilute acid. Only the metals that are higher than hydrogen can displace hydrogen from dilute acid. So talk about these metals now. They can displace hydrogen because they are higher than hydrogen. But the one below hydrogen, this copper to platinum, they cannot react with acid because they cannot displace hydrogen away from acid because they are lower in the activity. You can imagine your teacher teaching in class now. If principal want to enter the class, the principal can displace the teacher from the class because the principal is higher than your teacher. So when principal enters, the teachers will be displaced. But if principal is addressing the assembly, a teacher cannot just come and say, okay, principal, leave, I want to talk to the children. That is an aberration. That will not work. So a teacher cannot displace principal because teacher is lower than principal in the school organogram. The same way, metals that are lower than hydrogen cannot displace hydrogen, but those that are higher can displace hydrogen. So that is why not all metals can react with hydrogen, can react with acid to displace hydrogen. When hydrogen gas is released, you are going to note that hydrogen gas, because hydrogen gas is a colorless, odorless gas. It's a colorless, odorless gas that give pop sand. You call it pop sand with lightest splinter. It gives a pop sand with lightest splinter. What's the meaning of lightest splinter? Matches. You can see that matches that is having light is a lightest splinter. When you put hydrogen there, when hydrogen is inside that test tube, you wear pop sand. That's how you know that it's hydrogen. You can see that if you react magnesium with acid now, what you call it, the hydrogen gas will be produced. Then if you put a larger splinter inside, you wear pop sand. Pop sand. That's the test for hydrogen, a colorless, odorless gas that gives pop sand with lightest splinter. That's test for hydrogen. Let's see number 3, property of an acid. Chemical property of an acid. You are meant to note all these 5 and be able to use them very well. Acid plus carbonate plus salt will give you salt plus water plus carbon dioxide. I'm going to explain to you why it is like that. Acid plus carbonate is salt water. Carbon dioxide is an old name for carbon oxide. Let's see some example in this place. Sodium carbonate, or if you like sodium triisocarbonate 4 plus acid will give you a salt. You can see salt NaCl plus CO2 and water. We should have water here, not hydrogen. We should have water here, not hydrogen. That is mistake. Water. Now, how do we arrive at this product? Just calm down. The same way we have been doing it. Here we are having 2 units here, sodium and carbonate. Here we are having 2 units, hydrogen and Cl. You can guess which will go to which. Sodium will pick up the chlorine because they have opposite charges. So Na and chlorine. Valency of Na is 1. Valency of chlorine is 1. So invariably we're getting NaCl that we have here. Now H will pick up CO3. Now look at this very well and pay attention. When H picks up CO3, valency of hydrogen is 1. CO3 has a valency of 2 because it's 2 minus. Please pay attention very, very well. So when you exchange their valency, you are going to be having H2CO3 1. So that's H2CO3. Now, because H2CO3 is a weak acid and it is very unstable, it automatically breaks down into water and CO2. See how it's going to break down. We have H2CO3. Remove water from here. That's H2. I remove it now. Out of the 3 oxygen here, you remove 1. Here become 2, right? So put the 1. That's the water that we have formed. So now you are left with water and what? CO2. That is what happens when H2CO3 breaks apart. It breaks apart into water. H2CO3 will break apart into water and then CO2. That's what we're having here, CO2 and water. H2O here, CO2 and water. That is what H2CO3 breaks down into. So anywhere you have H2CO3, you don't write H2CO3 because it will not be stable. So just write H2O and CO2. That is H2 CO3. So let's see other examples here. Okay, let's talk about CO2 gas. How will you know that the gas is CO2? Just like hydrogen, carbon dioxide is a colorless, odorless gas. But in this case, that turns lime water milky. It